Hello everyone. In this video, I'm going to talk about what's called Hess's law, or this is a way of exploring the properties of a state function in order to be able to find the enthalpy of reaction. And so this is another way. Remember last time we talked about how to use the enthalpies of formation from a table to find the enthalpy of reaction. Hess's law is going to be another process that we can use to find the enthalpy of the reaction. So because enthalpy is a state function, the path that is taken does not matter in that total value for the enthalpy of the reaction. So that means that we have to know how to manipulate these equations, because what's going to happen is that we are going to look at a series of reactions and we are going to manipulate them so that we can know the enthalpy of each of the reactions and be able to find an overall enthalpy. And so if the coefficients in if a reaction is multiplied where its stoichiometric ratio increases by a factor, then you also must increase the enthalpy of that reaction by that same factor. So if a chemical equation is multiplied by some factor, then the enthalpy of reaction is also multiplied by the same factor. If a chemical reaction is reversed, then the sign of the delta H of reaction is reversed. And so in this example, I have delta H1 for the forward reaction, delta H2 for the reverse reaction is equal to the negative of delta H1. If the chemical equation can be expressed as a sum of a series of steps, then the enthalpy of reaction for the overall equation is the sum of the heats of reaction for each of those steps. So I have one reaction that is A plus 2B forms C with an enthalpy of delta H1. A second reaction that is C goes to form 2D gives me a delta H of reaction 2. Now, since I have C on both a product and a reactant, that whenever I add these together, they're going to cancel out. And so that means that my overall reaction is A plus 2B yields 2D, and I can find the enthalpy of this reaction by adding together the enthalpies of the individual reactions. Okay, so let's do an example. Let's see this in action. So if I have, so here's an example with numbers. Sorry, we're not quite to the try it out yet point. If I have carbon in the form of graphite plus O2 gas forms CO2, it has a delta H of reaction. This is actually a delta H of formation, but it's also a delta H of reaction because this is a reaction and that value is negative 393.5 kilojoules per mole. Or I can go looking at it as a two-step process where first I create carbon monoxide with my delta H of reaction is equal to negative 110.5 kilojoules per mole. And then I combust that carbon monoxide, the CO, with oxygen, creating CO2, which gives me a delta H of reaction of this. And so if I add these two together, the carbon monoxides cancel, leaving me and a half O2 and a half O2 add to one O2. And there's a 1 here. Giving me that carbon graphite plus oxygen yields carbon dioxide. And this delta H of reaction is negative 110.5 kilojoules per mole plus a negative 283.0 kilojoules per mole. Or if you add those together, you get the negative 393.5 kilojoules per mole, which is the same value that we got up here from doing this in one step. Okay? Okay, so now let's walk through an example that I'm going to work to figure out the delta H of reaction for the formation of ethanol using the information provided here. So the first thing with these problems is that you've got to figure out where you're going. And so the enthalpy of formation of ethanol is forming ethanol, C2H5OH liquid, from elements in their standard state. And so to do that, I'll need 2 carbon, and its standard state is graphite, plus 3 H2 gases, plus a half of an O2 gas. And so this is the overall reaction of where I am going. So the next thing that I do is that I start to plan myself. I start planning my work. So I look and I say at the equations that are given to me. And the first thing I do is I mark my products, and then I mark my reactants. And then I mark the things that I have to get rid of. Okay, and so there's a few ways to go about this. What I am going to do is the first thing that I am going to do is I'm going to work to make sure that I can get my reactants on the right side and my products on the right side. And so to do that, I need to flip this first reaction. I need to flip the second reaction. And I need to flip the third reaction. So I'm going to go ahead and do that. 2CO2 plus 3H2O goes to form C2H5OH plus 3O2. And remember, if I flip the reaction, then I have to flip the sign of the delta H. And so I have 2H2 plus O2 goes to form 2 H2Os. And my delta H is a negative 571.7. And for this guy, I have 2 carbon plus 2 O2s goes to form 2 CO2. My delta H is negative 787.0. Okay, but we still need to figure out, we have to get rid of our CO2 and our water. And right now, our CO2, we can, but our water, we have 3 as reactants and 2 as products, which means that they're not going to cancel out directly. And so to get them to cancel out, I'm going to multiply this reaction, this first reaction, by 2, and I'm going to multiply the second reaction by 3. But when I do that, I'm going to mess up my CO2. So I'm also going to multiply this third reaction by 2. And so what we get now is 4 CO2s plus 6 H2Os goes to form 2 C2H5OH plus 6 O2. My delta H, I have to multiply my delta H by 2 as well. Gives me 2737.6 kilojoules per mole. And then I get 6H2 plus 3 O2s goes to form 6H2O. And I have to multiply my delta H by 3. Gives me a negative 1715.1. And then I have 4 carbon plus 4 O2 goes to form 4 CO2. My delta H here, I have to multiply by 2, is negative 1574 kilojoules per mole. So now my waters cancel and my carbon dioxides cancel. And I have my reactants and my products where I want them to be. So I can add things together. So now I'm going to just add these guys. And so that's 6H2 plus 3 O2 plus 4 carbon. Oh, there's another O2. And so this means that I have actually 7 O2s. Goes to form 2 C2H5OH. I don't know why that's subscripted. Plus 6 O2. And the delta H is going to be equal to the sum of all of these values. So 2737.6 minus 1715.1 minus 1574 gives me a negative 551.5 kilojoules per mole. But I'm not quite done yet. Notice how I have O2 on both sides. So since I have 6 O2s here, those will cancel and leave me with actually 1 O2 on this side. And that's a freebie. Now, the next thing to remember that our overall reaction that we were going for was actually C2H5OH being produced from 2 carbon plus 3 H2 plus 1/2 O2. If you notice, that's not what we have. We have 2, we have 4, we have 6, and we have 1. And so that means that really what we are going to have to do is divide this by 1/2 in order to get to where we want. And so if we divide this by 1/2, we get 3H2 plus 1/2 O2 plus 2 carbon goes to form C2H5OH with a delta H equal to negative 275.75. And this is my final answer. Okay, I know that these problems get a little long. They often require some trial and error. I recommend that you spend some time practicing Hess's law problems so that you can start seeing the patterns of how to go about manipulating things. And you're going to have to create a pattern that works for you. Because, and these problems, like a pattern that works for one of these problems is not necessarily going to work for another. They often require some trial and error and some working with them. So, good luck. I hope you practice these. I hope this helped.